Hi folks, it's already 9:30 and because we have a full agenda today, let's start. So good morning, welcome to the V6OPS session. My name is Xiteng Xiu and together with Ron Bonica, we are the chairs and Fred Baker is our advisor and Warren Kumari is our AD. First, I would like to remind you of the IETF note well. I hope you are already familiar with it. Here, I would just like to emphasize that we work as individuals and please be nice to each other. Two housekeeping issues. If you haven't signed the brochure already, please point your mobile, scan the QR code, or we have a pad that we are passing around the room to log into data checker and sign on. Also, when you want to get into the queue, please use your mobile to get into the Meet Eco queue before we walk to the mic. So today we have 4 working group drafts and 6 individual drafts. So time is tight. And I would also like to tell you that on Thursday afternoon, we have a side meeting. We invited Amazon AWS to share their IPv6 deployment experience. We also have a topic on US government IPv6 mandates and how it affects the global company doing business with the US government. And Philip and Nick and also George Dioger from Dell will share their experience. The working group draft are steadily increasing, so that's good. The individual draft dropped a little bit, but nothing alarming yet. It's mainly some draft become working group draft, some draft get expired. And in terms of number of attendees, we are stable around 120. And as a matter of fact, it's 128 in IETF 117, which is a recent record, even though that it's slightly more than previous. I would also like to remind everyone that IPv6 deployment facing these 4 challenges. One is this lack of motivation, lack of knowledge, legacy support is still not very good, and also some operation issues. To deal with these challenges, for example, the lack of motivation, this is why we are inviting a lot of successful deployment to share their experience. To deal with the lack of knowledge, Brian Carpenter is leading this effort to write a free IPv6 textbook that can be used in college. So this time we have 10 contributors and 321 commits, compared to the previous IETF is 9 contributors and 293 commits. So we made a little bit progress. We really need more. So Brian is calling for more support, and we really hope that more people can contribute. And the next thing is the enterprise IPv6 issues. Mike and Lily and also Philip, Nick, they are all working on this. And again, we call for more contributors. There are some other interesting tasks. So on Sunday, I gave this Hawk IFTC talk to point out the disconnect between IPv6 user adoption rate and traffic rate, because according to Google, the IPv6 user adoption rate is 40+%. And they should imply at a traffic level of 27% or more. However, I think based on some anecdotal data, we are seeing that the traffic percentage is actually way lower than that. So what is the reason? Maybe some technical issues are hidden behind it. And we are hoping that we do an investigation on this. And also, we know that IPv6 packet loss rate with extension header is pretty high. But what is the packet loss rate for generic IPv6 packets? Is it higher than IPv4 and why? I think that this is another interesting topic that we can investigate together. And we really also hope for somebody can articulate the IPv6 advantage over IPv4, because this will be an important motivation for enterprise to move on to IPv6. So this is the working group status. Next, I will move on to the draft presentation. I will start by giving an update on the ND consideration draft. This draft is about 3 things. The first thing is a review of node ND issues. Our draft contributed by pointing out that these issues came from 3 cores: multicast, trusting or host, router, NCE on demand. So multicast in a wireless environment or in a large L2 network can have some impact. I think that this is not difficult to understand. Trusting or host in a public access environment may have some issue because some of the hosts may not be worthy of trust. And also NCE, router NCE on demand in a equal delayed forwarding. And in a high performance computing environment, it may have an issue, and also it may cause some NCE exhaustion. So we see a number of issues. To deal with these issues, there are existing solutions. If we look at these existing solutions, we can identify that there are one thing in common, is like they all use some kind of like host isolation to deal with the issues. These host isolation, we identify 5 of them from this solution. Is this subnet isolation, or this is unique prefix per host. And then there's also P2P link isolation, P2MP proxy isolation, and GUA isolation. I think that why isolation will help to prevent some ND issues, because again, I think that, you know, when we look at the cost, isolation, of course, will reduce multicast. Isolation will also reduce the number of hosts that you need to trust. With many of these solutions, they all proactively install the neighbor cache entry. So this is why this isolation approach can help. Here, we would like to point out that we are not saying that you must always do host isolation, but in the end, we give some guideline, and we believe that it will be helpful before your deployment to go through this guideline, and then depending on your deployment scenario, you can find out whether, for example, is multicast an issue in your environment. If it's a large L2 network, then maybe it is, and you should consider that. But if it's not, then you know you don't need to worry about the potential issues. So we believe that such a guideline will be useful for and because these 5 isolation methods are not independent. So when we combine them, we don't get, you know, 2 to the power of 5 or 32 different combinations. Actually, there's only 6 meaningful combinations, and we list them here. These are the subnet isolation plus P2P link. So this one, subnet plus P2MP, subnet with just shared media. So these 3 isolations are basically layer 3 isolation, meaning that they all employ some kind of unique prefix per host. They also do the with different degree of L2 isolation, ranging from, you know, P2P, which is complete L2 link isolation, to, you know, no link isolation. And the next 3 isolations are proxy isolation, GUA, and no isolation at all. These 3 are basically, you know, no layer 3 isolation. However, they also have different degree of layer 2 isolation. So the important thing is that these 6 combinations actually are covered all paces. because they, layer 3 isolation, either with layer 3 isolation or with no layer 3 isolation. And then from a L2 isolation, either with L2 isolation or no L2 isolation. And then GUA isolation or without. So, it covers all bases. This may give more confidence to the guideline because it covers all bases. And also, for each of these isolation methods, we list the applicable scenario so that you can see if, okay, this is applicable to your deployment scenario or not. And we also list the entry requirement. In order for you to use a particular isolation method, what kind of requirement you must meet. And then, if you use this particular isolation method, what are the remaining issues and solutions? Generally speaking, the stronger isolation you apply, then you will have a higher entry requirement. But then you have fewer remaining issues, and you need fewer solutions to deal with the remaining issue. So overall, the final solution may actually be simpler. I think that this is the purpose of this guideline. Trying to let you choose, a suitable isolation method. So in this version, we do a big update. First, we point out that, certain ND issue only in certain environment. For example, again, you only need to worry about multicast if it's wireless or it's a large layer 2 network, like this, just to address the concern that this may give a negative impression on ND. And then the bigger change is on proxy isolation. We're basically pointing out that proxy isolation is for all the hosts in the same subnet, which meaning that there's no L3 isolation, but it basically, divided it into all the hosts in the same subnet into different groups. And each group will have its own multicast domain. As a result, it reduces multicast. This is some sort of layer 2 isolation. So this way, I think that the relationship between proxy isolation and its relationship to L3 isolation, L2 isolation become clear, and it helps us to see that the 6 isolation method cover all bases. And the last one change is that we point out that unique prefix per host or L3 isolation will reduce privacy. So if privacy is very important, then maybe you want to avoid using unique prefix per host, or you want to, in addition to unique prefix per host, you may want to introduce some other mechanism to deal with privacy. So overall, we believe that the draft is now relatively stable, and we hope for more review and comments. And we want to thank Pascal and other people for some pretty thorough review in the previous round. And we plan to ask for a working group last call in the near future. And that's on this draft. Any questions? If not, we will move on to the next presentation by Pascal. Please go ahead.
Hi, I'm Pascal Tuber. I'm with Cisco. Next slide, please. Okay, so I'm here to present you some work which is happening at 6man, but may have some impacts with 6hops, and is in actually tight relation with the work that Shipeng has just presented to us. So I thought it would make sense to just present them back to back. And the overall point of that document is to work on an architecture for doing IPv6 over NBMA network. IPv6-ND in particular is suited for point-to-point and transit networks, but it is explicitly written in the document that it is not designed to support NBMA. As it goes, NBMA has been a long-standing promise, as Sota-san told us recently on the NOG. A long promise from V6, which was actually never held. So it could be time, considering the shape that modern networks take, to actually tackle that problem. And some examples of networks which happen to be NBMA are wireless networks, as you can find in OCB for .11, or in IoT networks. That's where this work started. But it's also the shape that modern infrastructure take now in campus networks and enterprise networks. Like if you go to BES and look at what EVPN is designing, it is a NBMA network based on a mesh of EVPN tunnels. So it's exactly the sort of thing we're talking about. And the design that EVPN is taking is pretty much an instantiation of what we are discussing in this document. So the idea is probably for IPv6 to catch up with what is already done. Actually, it's not reinventing the wheel. What we propose here is IPv6 level adaptation of exactly what Wi-Fi is doing to extend a BSS into an ESS. It's a multi-op network. You have wireless access, and then you've got the Ethernet backend. And basically, there is a proxy function at the edge by the access point. That's what it is. So the Wi-Fi stay registers through association to the learning bridge that is the AP proactively before the MAC address is needed, so that it's there when it's needed and you avoid the broadcast. So this same architecture actually relates to the way a frame relay worked in the mid-90s when you did OSPF v2 and the point-to-multipoint design. What we are doing here is the exact emulation of P2MP for IPv6. The draft starts, and we'll see that with why we have a prime, and effectively the bottom line of that is the way IPv6 ND works, and in particular, the way Slack works, is not friendly to modern infrastructures that need to know which IPv6 address is where at every point of time. We need to know all the IPv6 addresses in the subnet, and we need to know where they are. Because after that, there is an infra that's being set up like EVPN. And to have a correct view of the network in EVPN, you need to have a proactive, full, perfect knowledge of each address and its location. Otherwise, you will turn on the packet to the wrong place. It's not going to work. And the way it's being done today is pretty much by snooping Slack. And in the real world, we happen to have primes like what we call BUM in general, which is broadcast, unknown, and multicast, which always end up in this tension between will I broadcast a lookup, or will I prevent reaching these devices? If there is a device that you missed snooping Slack, then either you don't reach that address, or you have to broadcast in the full network, which could be a subnet that extends over continents. So that's basically why we are looking for a method that will ensure that the infrastructure knows for sure at every point of time, not only which MAC address is on Wi-Fi, well, every MAC address is on Wi-Fi, but also where every IPv6 address is. Now, the draft lists another number of mismatches, but I mean, please go through the draft. Next slide, please.
Next one.
Oh, that's the one. Okay. No, I'm sorry. I didn't see the switch. So one of the big bottom lines of that draft going from transit to NBMA is to realize that it was actually a design point for V6 at the time where we wanted probably that the transition from V4 to V6 would not be too hard. It was a design point to design V6 the same way as V4, design ND the same way as ARP. Like, in particular, and the most important for us here, have a one-to-one mapping between the broadcast domain at layer 2 and what we call a subnet at layer 3. And that's how you can do a lookup with ARP and with ND. But the problem with that is if you come in a building like this, and you would like to get an IP address from the IETF that you can use as you go from room to room, the one hand. But when you do bonjour and locate a printer, you would like the one in the room to print for you. then you realize that the subnet, which is the full building, and the broadcast domain, which is this room because that's where the printer is, are not necessarily a good match. You would really want to decouple those two. I have the same thing with EVPN, right? If I do a broadcast in one of my campuses, I don't want for looking up a printer. I want to again, find my printer in this campus, not somewhere else in my corporate network. Okay, so the bottom line is, if we want to be able to build any network we like, there is a huge value in decoupling the layer 2 concepts from the layer 3 concepts. And this way you can really operate V6 the way you like, independently of whether this subnet is composed of a single type of links, multiple type of links. I can connect IoT devices through 15.4 onto my same subnet as some normal host. You can build anything you like if you decouple the subnet from the broadcast domain, and even from the type of MAC address.
Next Pascal, you have 3 more minutes.
Yeah, but I passed my message already.
Okay.
So now quick status on document, but it's mostly for consumption by 6man. But just to give you history, so it started with a draft specifically about wireless. And there is still some huge taint of wireless in it. I want to clean that and give more examples which are not wireless. But it started with a document explaining why IPv6 and indeed SLAC in particular are not fit to wireless. And as the document went adopted in 6man, and since Bob, you're here, please fix me if I don't spell it right. But I was asked, publication time, to focus on the architecture concepts that were in the document, as opposed to the prime statement. Next slide, please. So we end up with a document which really has 4 sections. And the first section, this one, is probably the one which is of the most interest for V6OPS. And if you could come back to me and with comments on that piece, that would be really appreciated. And if I'm missing some issues, etc., really appreciated. There is some overlap with Shipang's document. If you have proposals on how to fix this overlap, but basically it's saying less precisely what Shipang is saying, and it's giving more examples. Right, so we're going through overlays, sustainability, privacy, middle box. There are all sorts of issues which are listed there. Next slide. Then comes the core of the architecture. And that's one thing that I didn't really find in any IPv4, IPv6 document. It's probably high time we define them, is what are those things that we call links, interface, subnets, and proxies. So I tried to come up with a definition, and really we need the group to agree on some definition. So this is starting point for that. The key thing is, because now it is not just a plain mapping, a plain copy of whatever the L2 guys do, then we have to define what we want them to be. It's no more, oh, take your broadcast domain, that's your subnet, gone. Okay, so what is my subnet? What's my link? If you look at MANE, in MANE cases, we have defined the link not to be a radio because it doesn't mean anything. A radio can connect to those guys and the next second to those guys. If I did that on my MAC address, on a link local address based on my MAC address at time equals 0, 5 minutes later, I'm far, far away. I can see very different people. Is my link local address still unique? I have no idea. So mapping a link local address and link to an interface makes no sense. So in MANE forever, and in 6LoWPAN as well, we have mapped a link onto a peer-to-peer connection. 2 guys are talking. For those 2, this link local address is unique. Okay, now we have done that. Okay, this sort of concept needs to be defined. It was used already for a long time in MANE and 6LoWPAN. Let's agree on them in IPv6. Next slide.
Please wrap up in a minute.
Okay, I'm done. So after that, we present a framework, which is basically how we've already done most of that in a more specific context, and we want to generalize this, but at least we give a proven framework of things which were done with existing RFCs. And there are actually millions of nodes which do exactly that. They are not deployed in PCs, right? They are deployed in this very city. If you see PG&E written somewhere, you will see those things implemented in them. But millions of nodes prove that it works. Next slide. And that's my last slide. The last piece of this document is actually an applicability statement. I've just written the ones from wireless. When I say this draft is still tainted with wireless, so you still see wireless in there, but it's really applicable to many other types of networks. So my conclusion here, because I need to give one, is there is a missing link between a host talking, say, to a DHCP to get an address, to get a prefix or whatever, and the routers which need to do something out of that. Whether you ask a prefix, whether you ask an address, whether you autocount that address or that prefix, there's still this gap between DHCP, which is authoritative to give it to you, and the routers which have to trust you for owning it. And part of the things we have to do, and this draft does, is closing that gap, ensuring that everybody is in sync, the DHCP, the router, the host, without what we find today, which is a proprietary connection between the DHCP relay and the routers. That's how we do it today, and it's kind of unclean. That's pretty much it. So reviews would be really, really, really welcome.
Lorenzo, please be concise as we are running out of time.
Yeah, so two points. I think, first of all, architecturally, this draft is focused on ND, but everything you said is actually not specific to ND. ND is an application that uses broadcast and multicast, and there are lots of those. There's multicast, there's Bonjour, there's all sorts of stuff on link discovery. Lots of applications roll their own stuff. Yep. And all of them have the same sort of properties. And so
I just said no, actually. I gave the example that you gave of Bonjour, and the need of Bonjour might be just limited to this room, whereas the need for ND could be the whole subnet. So I'm talking about IP application. So you're right, but not to, we actually want to decouple what Bonjour sees and what IP sees. That's exactly right, one of the goals.
That's why I'm saying this document is too focused on ND. If you want to change, if you want to define like multi-scope subnets, that's a big architecture problem, kind of like researchy territory. But like, I don't think you can just focus on ND, because ND is just one application that uses essentially, it uses flooding. It's sort of like a service discovery problem, if you think about it. You want to discover an IP address.
I understand that. The question is, the difference that you don't seem to see here is ND is the one that needs to match the broadcast domain, quote unquote, with the subnet. Whereas most of the others that I'm aware of, they're happy with the broadcast domain that layer 2 gives them. And actually being able to give them a layer 2 domain which fits their needs, a broadcast domain at layer 2 that fits their needs, and still be able at IP layer to do IPv6 the way we want. And actually what defines the subnet is the scope of ND. That's it.
I don't think it's I don't think it's a foregone conclusion that ND needs to match, is not happy with the subnet broadcast, but with the broadcast subnet. I don't think that's true at all.
Well,
folks, I'm sorry.
Please comment on the mailing list on the text. Yes, on that. But I'm giving examples where it's not happy. I'm not saying it's never happy, right? I'm saying there are good cases now where it's not.
And the same examples apply to other broadcast apps. The other thing was, the other thing is like what this document is lacking is the for ND specifically now, it is the balance between sort of hosts and network infrastructure, where there's an unwritten assumption, or maybe written assumption in this document, that the network must be aware at all times of everything that a host might be wanting to do, what sort of IP address it might have. And Slack was kind of intentionally designed in an opposite way, where like the host actually can form an IP address without telling the network. Yeah. And there are advantages.
I agree with that.
I'm sorry, Pascal and Lorenzo, I will have to ask you to take the issue to the list, because I think we can spend whole day here.
I just made my point. That's fine.
Yes. And my short answer is
thank you.
Applicability is not general, and we need to work on the applicability statement for this, because I agree with what you said.
Okay, thank you. Chongfeng? Chongfeng, can you hear us?
Yes. Can you hear
me?
Go ahead. Okay, thank you. Okay. Hello, everyone. I'm Xie Chongfeng of China Telecom. I'm very pleased with this the progress of framework for multi-domain IPv6 only identity network and IPv4 as a service on behalf of all the courses. Next, please. Next, please. This draft was adopted after IETF117. The current version is 02. I can't see the slides, Xipeng. The current version is 02. Its purpose to provide end-to-end IPv4 service delivery over multi-domain IPv6 only identity networks, and eliminate unnecessary IPv4, IPv6 converted in a scalable way. Now the comments have been received since.
Now, which slide do you want to be in? We are at slide 3.
Yeah, it's okay. It's okay.
Can you see the slide now?
Yeah, it's okay.
Okay.
We really appreciate that. Next, please. These are the new revisions to this draft. Yeah, I can't see the slides.
We're now on slide 4.
Oh, slide 4. Okay. The following sentence. These are the new revisions to the draft. The following sentences are added in section 1, section 4, and section 6.1 respectively. We also changed some words. One need was fixed. Next, please. While improving this draft, we also set up a multi-domain IPv6 only testing network. The network consists of AS1, AS2, and AS3. The edge routers such as P1, P2, and P3 and P routers are located at different AS. So this mimics a multi-domain IPv6 only network. Each P is configured with different IPv6 mapping prefix. Next, please. In this test, P2 is connected to IPv4 Ethernet. It lends a IPv4 routing item 110.242/24. Then it generates the new mapping rule, which consists of the IPv4 address block and the local IPv6 mapping prefix. Then the mapping rule is announced in the form of BGP updates to IPv6 peer routers. The BGP update will be received by P router, as shown in the picture on the right. This is a composite IPv6 routing generated from original IPv4 routings. Next, please. The BGP information continued to be flooded. When P1 received the BGP update message from its labeling router, it will validate the received BGP update by finding the FORMAP6 attribute, then extract the IPv6 mapping prefix and IPv4 address block from an IRR field. After that, it will restore the mapping rule and store it in the local database. Moreover, P1 also needed to redistribute the new IPv4 routing to the local IPv4 routing table. Next, please. The test network can support various communication modes such as IPv6 to IPv6, IPv4 to IPv4, and IPv6 to IPv4. We have tested this framework in the case of Nexus 4. Nexus 4 is a typical technology for IPv6 only. We all know that in traditional Nexus deployment, the upstream transit core is still IPv4. When the new framework is introduced, IPv6 only data paths can span local network and the transit core. The function of Nexus 4 and the adapt can converge in P1. The ingoing and outgoing interface are both IPv6. End-to-end IPv4 delivery over IPv6 can be achieved. This is a result IPv6 host ping IPv4 internet server. The test used 3 types of IPv6 hosts: Windows, macOS, and Android. This test has proven that this framework in the draft can work. Next, please. The next step is to collect the comments and the suggestions and make a further improvement to this document. And we also plan to demo in IETF117 if the condition can be met. Thanks. This is it. Xipeng, thank you.
Thank you. Any questions? If not, thank you, Chongfeng. We move on to the next.
Hello, I'm Jen, and we're going to talk about allocating unique prefix per device using DHCP-PD. Next slide, please. Next slide, please. So, what happened since last IETF? And actually, previous slide was saying changes, but I am also going to talk a bit about concerns and questions which were raised during the adoption and review. So the main change we've made was the most controversial topic is about prefix length. The draft now does not say 64. That trigger was removed. I think if you search for 64, you'll only find it in a couple of examples. So draft doesn't prescribe prefix length, whatever works using Slack. So basically we are saying the network should provide prefix which is short enough for clients to use Slack. If people have energy to go to 6-man and change Slack to whatever prefix length you'd like, with my 6-man heads on, yeah, we can discuss this. But this is operational draft, this is V6OPS, we are not changing protocols. So if we change prefix length in future, this draft will still apply. So it was a lot of questions on the list, why Slack at all? We're developing something new, let's forget about Slack and start using some new shiny things and assign, I don't know, 1/26 per interface. So I realized that picture is worth of 1,000 emails. So next slide, please. Let me explain why we cannot just forget about Slack. So what's going to happen? How I would expect this to be deployed? You might have a physical device, such a laptop running Chrome OS, for example, or some custom device which you might perceive as a host because you plug it into access port of your network, like treadmills. If you remember 3 years ago, I was talking about how we migrate the network to V6 only, and the first thing I broke was treadmills because and smart scales in the kitchen. And I opened smart scales with a screwdriver and I found it's not a host, it's actually a router. It's 4-port router inside and a couple of devices connected. So you might think it's a host, but it's actually a router. And that device, that router part of it, or host operating system in case of virtualized environment, will send a PD request and will get a delegated prefix. But systems using those prefixes to assign addresses might be logically different systems. For example, in case of Chrome OS, we are talking about some virtual devices, virtual systems, which will receive that delegated prefix or part of it if delegated prefix is shorter than /64 and would use Slack. So we basically have some logical separation here. One system will implement DHCP-PD client, but the systems using those prefixes for Slack might be different systems. Similar actually for tethering, right? I might take a phone, the phone will ask for a prefix and it might provide that prefix as for tethered devices. So an idea is to localize the changes and do not invent new things here. We basically, again, it's V6OPS. We're using existing building blocks to build a new deployment scenario. Next slide, please. That's a very interesting topic about terminology. There are things which we kind of understand on the subconscious level, I would say. Like there are routers, there are hosts, there are endpoints. But if you look deeper, as I just gave you an example about like treadmills, smart scales, you cannot necessarily define what is a router, what's a host. So it was two concerns about this. First, people say, we don't want routers in my network. I only allow hosts to be plugged into access ports or connect to Wi-Fi. The problem is it's really hard to tell what you actually plug in, right? You have a physical box, it's one Ethernet port, what's inside? Maybe a router, maybe a host. You really don't know. Because in IPv4 world, you would not even notice that, because whatever is inside will do IPv4 NAT and will be happy with a single IPv4 address. But as soon as you start turning off IPv4, there will be some very unpleasant surprises, right? It was another thing which I broke immediately when I deployed a v6 only guest network, right? All those devices which were relying on NAT in IPv4 to provide connectivity to some hidden subsystems. Next slide, please. So basically, yeah, illustration, what's happened? You have a dual stack network, you have a physical box, inside it is a 4-port open WRT device, which will get a v6 address using Slack, will get v4 address via DHCP, will do NAT, and will send a v4 traffic, providing v4 connectivity to whatever hidden inside. Now, I'm going to my network, SSH to my router, turn off IPv4. The router still gets v6 address, but there is no connectivity for whatever is behind the router, right? So unless we require those devices to always use 464 slot, right, and keep v4 network downstream and not it to upstream, those devices behind the router are totally broken, right? Definitely not desirable. So if we start providing PD, so actually even before we start talking about this draft 3 years ago, I realized that on my network, I actually should provide PD by default ideally, exactly to cover those cases, because those routers actually quite often are capable of sending PD requests by default and provide connectivity over v6 to devices behind it. Because yeah, if you provide v6 prefix delegation, devices behind the router will have v6 connectivity. Next slide, please. So basically, yeah, if you have full control of your endpoints, right? It's completely like enterprise network, everything managed. You cannot do anything. Users could not do anything with endpoints without administrator now. Then this draft doesn't introduce any new concerns, right? Because you know what devices are doing. You can disable or enable PD as you want. However, if you have uncontrolled device, unmanaged device in your network, you basically have 4 choices. Choose one, right? You can keep devices broken, or you can keep IPv4 forever, because those devices would need some connectivity, and you cannot give them connectivity unless you force them to do IPv6 NAT, right? But have I just said IPv6 NAT? Horrible, no. Or the most obvious solution is just give them enough address space, give them a prefix, and they will be perfectly happy. Okay, next slide, please. Again, back to terminology. Another argument we had on the list was about like hosts by definition is something which is like final point, right? There is nothing downstream of it, so why do they need this stuff? Routers already do PD, so router basically do not need this draft. If you have routers, great. They are supposed to do PD already. There is a CP router requirement. So why are we talking about this? First of all, as I said, it's really hard to tell now what is a router, what is a host. Is my mobile phone router or a host? Is my Chromebook router or a host? Actually, both. Even the routers, like we looked at CP requirements on Sunday, and CP requirements doc saying that router is must support a Slack 4862. And 4862 is explicitly talking about hosts. So kind of router also has a host subsystem there. So like it's really hard now to say, oh, this is router, this is host. So we actually updated the draft to use term device, exactly because it's, as soon as you start saying host, people will say, oh, no, this is also applicable to routers. So we cleaned up the text, and text should now say devices. Also, there are 2 things which this draft proposes, right? One thing is more devices going to send PD request, which is kind of unusual thing. But the second thing is actually, doesn't matter what you connect to your network, just start providing PD. Because even if Android phone or Chrome OS start sending PD requests, you might already have devices, routers, CPs hidden inside your boxes, which might use those delegated prefixes, right? Next slide, please. Well, so it was more like fundamental discussion, fundamental changes in the draft, and it's been some less critical but still important changes. So we clarified that devices should use DHCP bulk list query, because basically if the routers got rebooted, especially if you have multiple relays in the network, right? Network infrastructure should support DHCP bulk list query. So if your router got rebooted, it will recover the information, right? Because otherwise, yeah, you might get very inconsistent state. DHCP PD seems to have some uncertainty about how to operate in the scenario when you have multiple relays. Next slide, please. Yeah, a section been added about on-link communication, because while if you classically using the shared /64, obviously devices can talk to each other on link unless there is some form of isolation. So if you do have some form of isolation like private VLANs or ACLs or whatever, this draft does not change anything, right? Nothing is on link anyway, so devices will be still talking through the router. So using PD or not using PD, traffic flow doesn't change. However, if for some reason the particular network does allow peer-to-peer communication, on-link communication, things could become interesting. Obviously, by default, if host devices, start talking to each other using delegated addresses, they are not on a link. So the traffic will be hairpinned via router. And there are two options, right? Your router, you either just allow this and say, okay, or you might want to use ICMP redirects. In this case, administrator might want to make sure that redirects are enabled on the router and actually enabled on the host. Because, for example, like macOS, as far as I know, can allow you to disable processing ICMP redirects. It could be a part of corporate security policy or something. So if on-link communication is desirable, we need to rely on redirects. Next slide, please. Yeah, next step. Actually, any like fundamental issues besides Slack. And the authors believe the text actually is pretty stable. Yes, I do like 0.0 to be ready for the working group last call. So we actually would like to ask the group, the chairs and the group for working group last call on this. And that's my last slide. And we have 7 minutes, 14 seconds.
So you guys use the terminology device. You might want to consider using 8200 uses node for any device that supports IPv6. So that might just solve your problem in that if you read the definitions in 8200, node is anything that implements v6, router is anything that forwards it, and host is anything else. So I would just do node and get yourself out of a terminology fight.
Thank you.
So Pascal is actually next in the queue.
Please go ahead.
Okay. He's going to remember his question. How does this relate, if at all, to the work that's being done in SNAC?
That's a very good question. So strictly speaking, we are talking about the SNAC kind of assume you have routers, right? Which have something stub networks behind.
Well, so the question is, why is this node not a stub router when it's routing?
Well,
It's not? Why not?
Well, can we take this offline? Because I think I kind of start formulating an answer, but it might take longer than I.
As an author, I have an answer.
Okay, great.
I have two answers. Number one, lots more devices will support PD. Yay! You're welcome. No, because like that's, you know. But the second answer is like, for me, the fundamental difference between a stub router and a and this is that the stub sends up in some cases information about the connectivity of the network that's behind it, like the subtended network, where it does like RAOs and so on and so forth. This is not necessary because the delegated prefix is guaranteed to be provided by the network, and so connectivity is always working.
Yeah.
Yes, that's the difference.
Yeah. Thank you, Lorenzo.
And my question was, so Pascal Tuber Cisco, my question was about mobility actually, because I see a lot of value in this approach. One of them not being listed in your discussion, and that's mobility. So the question is really, okay, I'm in this hotel again, and say there are multiple subnets here, and I'm getting a prefix delegated to my phone, and so some application and whatever my phone does inside get addresses from that. And what I would like to do, since now it's a route to my prefix, is I would like to be able to roam in this hotel and not necessarily stay attached to the same link. You see? And so is it something that you have in mind on how to do it? Because it looks useful.
So I think we kind of indirectly saying it somewhere in the draft, because I think the draft does mention VXLAN scenarios as a use case. So basically, instead of having 25 routes, right, for each address my phone might have, right, we now have one route for a link local, yeah, and then you have a route for delegated prefix to that link local, yeah. So as long as your link local address is properly located by the network, yeah, yeah. So I think we saying this maybe not clear enough, yeah. So
I do have an answer. I don't know if it's necessarily the answer that will work for you, but the answer is that when you change link, you do issue a rebind. And if the network magically knows how to move you, it can move you, right? Normally, the other part of the answer is like that. Normally, the prefix is tied to the link local address, which is kind of scoped to a link. So, but if the network knows how to be smart and like move you around, then it can just do mobility. I think that's yeah.
That's
okay.
where I want to go. So I will start there for this, but I would like to be able to have this exactly happening.
Yeah.
So Jane asked this question of WG last call. So we just have this poll, and I think that we probably need to give more time for people to read the draft and then comment.
That's why I'm asking for the last call. People only read drafts on adoption and last call. That's the whole reason I'm doing this.
Yeah. Excellent. Thank you. Dale.
All right, thank you. I'm going to reset the timer. I'm going to need that. So my name is Dale Carter. I'm part of the Energy Scientists Network for purposes of this discussion with the U.S. Department of Energy. With me also today in the room is Tim Chon from JISC. Next slide, please. So sort of give you a context of what we're doing. So we're working in the realms of particle accelerators, detectors, colliding atoms, and making subatomic things happen, and then measuring those results to further the frontier of human knowledge. So to do this, it's taking massive infrastructure and machines and creating giant piles of data sets that then have to be analyzed. And no single entity can do this sort of analysis. So we see a deployment today of about 170 sites that are ingesting data, doing different computations upon that, sending it back out. Other sites are pulling that, doing more work. So it's a very computationally expensive workload that's very, very data heavy. Next slide, please. So just to give you a sense of scale, we're like at 1.5 million cores across all these sites. The individual flows are small. The file sizes are not big, so therefore it's perhaps not a surprise. The size of the flows is not that big. And we're running all of these things mostly on dedicated purpose-built networks. So we have some overlays that I describe in the draft, But most of these are what we call like the research and education networks that are, again, like I said, highly tuned and exclusively carry some of this traffic. And interestingly, because of where we are, the traffic we're talking about is almost exclusively IPv6. So one of my co-authors, Sean's site at the University of Michigan, I looked up at our stats portal, it was 80–90% IPv6. So we're presented with this worldwide scale problem with data movement and trying to, optimize, the use of the network in a very expensive links such as like transatlantic components. And to get some telemetry insight into what's happening in aggregate, we've come up with a solution to mark individual flows and packets with the owner and what they're doing. So what we have here is what we've deployed today, and curious if the working group is interested in adopting it. So being a pragmatic bunch, we wanted to use existing technologies today because we have real problems getting, in a couple of years, we'll be at exabyte scale data sets. And then down the line, we're also talking about potentially using the solution for traffic engineering. Next slide, please. So here's what it is. Here's our, our IPv6 header, which we all know and love. And then in there is the flow label. So what we're doing is we're encoding into here the community identifier, as we call it, which is essentially what user community of which you're a part. And then the activity identifier for what are you doing? Is it data set movement? Is it backups? Is it pre-staging data before analysis? Is it analysis products that have to go off for future work? And then to play nice with the world, we're still sprinkling in some amount of entropy bits into here. And then we take all these labels, collect them in near real time off the routers via IPFix or SFlow, and present up aggregated statistics that let us understand the traffic patterns of what's going on. And then we have a registry which maps all this together, that decodes this. So next slide, please. So, and this is sort of a laundry list of the way I think, like, is this legitimate, right? So there's well-documented use cases for how we're going to use the IPv6 flow label, particularly as entropy into ECMP and lag hashes. But 6437 says it's only recommended that the hosts use a uniform distribution and keep that as random as possible. Clearly, we're not doing that when we're closer to 32 possible values for any one given use case from a given host. And RFC 8200, it says, well, you need to treat these packets in the network as a single flow, which is essentially what a host is asking by setting these labels. And then, of course, there's load balancing. It doesn't really apply to us. But we have a bazillion source addresses and destination address pairs. So in our environment, which is rather restricted, we have plenty of entropy, not even looking at the flow label. And then as it's come up, again, is this a legitimate use? Well, I think the RFCs do document sort of some thoughts along those lines of your performance should not be dependent upon this and what's going to happen if someone's setting these randomly. And intermediate routers doing ECP or lag, which is the predominant use case at this point for these flow labels, if they're not set to 0, is to use a 3-tuple. Right, so you're going to take the V6 flow label and add it in. So like I said, this is a deployed solution today. We wanted to document exactly what we did and how it's working. And then if you hit the next slide, and then sort of how we got to this point, which is sort of a lightweight alternatives analysis of all the things we thought about first that seemed to really be a better fit. So obviously hop by hop options, well documented in, I've got a bunch of references in the draft, highly problematic, potential for drops if the router doesn't know what to do with it, even though it seems like we want a hop by hop option because we want the router to tell us what it did with the packet, but it doesn't quite line up right. Destination options kind of make more sense because we are talking about end-to-end signaling of intent for what was this flow about. But we have socket API problems where a user's unprivileged user space application can't just slap on a destination option header and call it a day. They're also buried deeper in the packet. So for a fixed pipeline ASIC to grab it and export it over IPv6 or IPFix may not be possible. So then, like I said, we're a pragmatic bunch. So let's try using unique source addresses per job. This has been trialed before in our environment. It's a hack. Marking the payload, it's encrypted. That's off limits. In the draft, I've been kind of keeping up on the idea of network tokens. Some of that's sort of like access control related, but could fit. It's sort of an emerging area. And then we also have developed, parallel to this effort, it's sort of an out-of-band telemetry system we call the Firefly, and there's some talk about in the draft how that works, and that's to be published later. So I wanted to whiz through this in order to save enough time for discussion. And my questions to the group are: is this appropriate for a working group adoption? I think it is. It's sort of demonstrating here's exactly what we did. Here's the problems we've encountered that I think will fit for future work. And I know today there's also some more discussions on extension headers, particularly that this could play into. So thank you. Hopefully we're keeping the pace moving.
Yes. So Lorenzo.
Hello. This is like I think it's the first innovative use of the flow label that I remember seeing. So that's no, I think that's actually pretty cool. Like, congratulations on finding a way to use it. I don't know what Steve Deering would say about that, but maybe be like, oh, cool. I think, yeah, I beyond curiosity around, like, do the routers actually look at the entropy? Does it work? That's something that I'd be curious about. I don't know if you've measured that. But like, for example, if you send flows with, if you do a sort of a flow with the same 5 tuple and you vary the flow bits, does it actually ECMP? That's just out of curiosity.
Right. Obviously very implementation specific.
Yeah.
And then we were deployed across.
But given that this is an operational working group,
Yeah.
that would be useful for people who might want to do the same thing.
Yeah.
And the other thing is, like, yeah, I wouldn't overthink it. I don't think, I mean, I just looked at 6437 and it's like, yeah, you should probably do this. You should probably do that. But I mean, it seems, I mean, I feel that, like, you can, especially in a closed domain like this, you can basically do what you want, I think. But
we want to be careful because, like a closed or limited domain is easy to wave, that banner around, but we're talking about 170 sites across the globe.
Yeah. You never know when the domain ends.
Yeah.
And like
Right.
you have concerns about, like, what if this escapes, but still.
Yeah.
I mean, in general, like, you can't really rely on that field containing anything useful outside a domain anyway.
And it's only means something to the source desk pair that use it. It doesn't mean anything to anyone else. Yes.
Hi, Bob Hinden. So I'm supportive of this work. I think this is meets the high level definition of the flow label. It's you want to put stuff in there that allows that the source of the traffic wants the packets to be treated the same. That's what you're doing. This is different than some other uses. I think I would call this a very large limited domain.
Yes.
So I think this is fine. Yeah, I'm not a little skeptical of that few entropy bits, but I'm not sure it matters very much. So, and it should be clear in the draft that you are documenting something that is operational. This is not some sense a proposal. You want people to learn from it, but you're not asking the IETF to say, is it okay to do this? You're already doing it. So it's important to document it.
Right. And that matches my intent of if it escaped the limited domain and you saw one of these in the wild, what's going on? Yeah.
Good. Thank you.
Hi, Tom Herbert. So I agree, this is very innovative, but the mechanism, clearly it's limited, right? So 16 bits of information, that may be good for this use case. It won't scale to hold more information, obviously. Flow label is by definition limited. And I would also note we're seeing not just this proposal, but I know of at least 2 other proposals where people want to basically mark packets with some sort of information, and that information is consumed by either middle boxes or intermediate nodes. In order to come up with a scalable proposed solution for that, I really don't see any other alternative than hop-by-hop options. And so I'm not saying that this work should immediately change, but I would like you to consider the use case of those. And also I'd point out, if you look at all the other alternatives, I wouldn't see any of those except hop-by-hop options as being something that we could actually standardize. In particular, I would probably remove destination options. We really do not want intermediate nodes parsing destination options. They're destination
Then
options.
encrypt them.
We have hop-by-hop options for a reason. So I think it's good work, but yeah, I would hope that we continue to look at this, and especially what would a scalable solution that could be used across, not even necessarily across the internet, even in limited domains. I think hop-by-hop options might be usable for something like this.
Yeah, and I think that deserves future work.
So, yeah, Tim Chan. Yeah, so I'd just like to say that's what we wanted to do at the start, the hop-by-hop option, but it's the implementation of it is tricky for the reasons Dale said. So that's why we came up with the flow labeling scheme, but we would certainly like to do hop-to-hop in the future.
So Warren Kamari, Google, no hats though. So could you go back a few to where you have the picture? I think it was the slide just before this. One more. So, I mean, I think this is fairly awful, but I understand why you did it, and I would probably have done the exact same thing. I am a little worried that you only have, what's that, 5 entropy bits left?
Exactly.
And I'm assuming people are going to find other cool uses and be like, oh, I want to use the first bit, and I want to use the last bit, and eventually we'll have almost none. Answering Lorenzo's question, it does look as though routers are using this, at least in the testing I did. I set up a flow and changed them, and like load balancing changed. So I think you do run the risk of, having an organization do something like this and then all of their traffic going down a single link because it would. I realize in your case that doesn't matter and you've solved that in a different way. So I think this is really cool. I think it's also a little hacky.
Oh yeah.
But I would have done the exact same thing. So
yeah.
Oh,
yeah. So we have large amount of source dust pairs. So yeah.
Joel Yeagley. I did an IEPG presentation a couple of years ago on my observations on flow labels changing on existing flows, which I did observe in the wild. And that did cause me to remove the flow label from my hash tuple on every router that I have in my network. I'm not saying anyone else should do that, but like it is a case that like did disturb us. And since we use hashing to like map flows to hosts, that was like an explicitly dangerous condition for us. So we did turn that off. It is on by default on Aristas for IPv6. So that is definitely a case where the default behavior is in fact hash over the flow label. And if you're not doing something stupid and stateful like I am on the in system, that actually is like not harmful. It might be, well, mostly not harmful. Sometimes it is, right? Like if you get a lot of flow label 0 stuff because you have a particular client that does that, might suffer from low entropy as well.
Thank you.
Okay, thank you. I think that we have to move on. Nanili.
Is that possible?
Yeah, I actually don't know how to make it bigger.
Can you don't have a touch screen?
No.
Hard to read. Yeah, anybody know how to do that? What kind of techies are we?
Oh.
You have a Zoom. Do you have a Zoom here?
Maybe like you sit here and present. I think that you can see better.
Yeah, I can sit here, but can everybody else? But nobody else can see either. Well, maybe you guys look in your thing.
People will just listen to you. Okay.
Yeah, people can just listen to me. Okay. How do you make it go next? This one?
Just
I want you.
if you want to go next.
Oh, do this one. Oh God. Okay. All right. All right. So I'll just talk. Okay. So of course I gotta see too. So let me just say right up front, we're doing troubleshooting. We call ourselves the Bug Brigade, B squared. We are not doing broad scale measurement. Let's just take that as a written. And we will do broad scale measurement after the problems that we find have been fixed. And it takes a while for people to roll out stuff over the internet. Two large provider of internet services have rolled out changes, and actually now 4 cloud providers are offering to work with us to fix their problems, and 2 router vendors. Next, please. So what we did, I think, we used we did an external hosting service. I think we've talked about this before. It is a no-name service. It hooks right up onto the internet with no intervening topology, and that is critical because any intervening topology you have in between yourselves and the internet can be a problem. What we did is we modified Ubuntu using eBPF running in user space. So we send a destination options packet with every packet that goes out, destination options header with every packet. We use Apache web server. So we're using real traffic, HTTP going out, not fake traffic. So let's not get focused on what cloud is or isn't. Let's just say for now, a temporary definition, it is if you go to buy cloud services and people say they provide them, Google, Microsoft, et al., that is what we are talking about. Next, please. So there's quite a few ways that you can do topologies. You can go from standalone like we are to inside the cloud. You can read. There's a bunch of different ways to do all this. And what we did, we took just 2 right now. We will do the rest. We did it from our no-name hosting service to inside the cloud, and then completely inside the cloud. Those are the 2 things that we did. We will do others later. Okay, next, please. So, okay, so here's the bottom line. So when our first test, we just want to make sure we didn't mess up the firewalls in this kind of business. And so with no extension headers, everything works just fine going to and from. And that's from the outside, from our no-name host to inside and vice versa. So the minute you put on extension headers, traffic going outbound or coming back in stops working. The OS supports it. We can see from the packet trace. And by the way, all the supporting information, all packet traces and with circles on exactly where things went wrong are in the supporting documentation. And I'm happy to go over the exact traces with anybody who would like. But that's what happened. The OS was generating extension headers, but somewhere within that network, somewhere between that host and the outbound connection on the cloud side, it was not getting out. When we were completely inside the cloud, both server and client were inside the cloud, extension headers worked perfectly well. Global unicast, link local, all of it with extension headers worked perfectly well. Next, please. I don't know what that is. What's the, yeah. So this is what we think the standalone cloud topology might be, but it's really not that. It really looks more like this. One of the cloud vendors that we talked to, what he said is that in between your server and how you get out, there's a number of third-party boxes. And as he said, we'll help you fix stuff, but first they're going to spend their time pointing at each other to see what the problem is. So next, please. Yeah. Cloud provider number 2, that was quite interesting, actually. It seemed to work the same way, outside to inside, and vice versa. It didn't work. Inside worked perfectly well, but they had a slightly different situation. They don't seem to compute ICMP checksum correctly, and it's because for some unknown reason, they have an external IPv6 address and an internal IPv6 address. And ICMP checksum is done over the pseudo header, which has the source and destination addresses in it. And if the addresses change, your checksum is going to be wrong. And they do it correctly if you don't have an extension header in there. But the minute you do the extension header, somehow the checksum is not computed correctly. We have escalated this at the vendor. Next, please. Yeah. So here's the whole thing about exactly what the checksum thing is. And again, as I say, the trace packets are attached. Is this the next one? Yeah. So next steps, we're gonna try and get these bugs fixed. Start testing with other people. We've already got one ISP who has offered their lab. We have a router vendor who is going to work with us, but we'll finish the other 2 cloud vendors first and then get them to fix their problems, and we'll continue testing while people fix. Any comments, questions, thoughts? You want to work with us? We're happy to have you. No questions? Okay, thanks.
Thank you, Nalini. Follow.
So good morning. Paolo Volpato. I'm presenting on behalf of the authors you see listed here on the cover page. Basically, the scope of my presentation is to give an update since the last IETF, so introduce the main changes we have done so far. About our draft, which you see from the title, is about providing site connectivity to, let's say, a site, a branch site, an enterprise site that needs redundant connections to provide always-on connectivity. Next slide, please. So you see from the diagram here, which is quite simple, actually, just to provide a high-level representation of the case we are discussing in the draft. Ideally, the enterprise or the branch site needs to be always connected. The point is that IPv6 based methods to provide redundancy do exist. They are implemented, they are used in deployment, but in most of the cases, they have some drawbacks. Not all the corner cases are covered. So the idea is to document through our draft all the available methods, the mechanisms you find in the field, discuss the pros and cons, try to, let's say, go through the history of the reasons why they were introduced and accepted and deployed in the field, and see, let's say, the operational impact about them. One important point you see it's underlined in the slide is that we try to give the point of view of the entire site, meaning that it's an architecture, a framework, which is owned, operated maybe by a single organization, for example, an enterprise, that has the full right to define the policies, the routing mechanisms, the filtering procedures for that specific network, which can be arbitrarily complex. You see in the picture, there are just a couple of CPEs connected to the host, but actually you have to think that in between there may be an entire network. And we're trying to discuss it at the network level. at most, I would say. Next slide. Now, from the last version, we discussed the IETF117. We have, I would say, reviewed the entire draft. So we have introduced a reference to the provisioning domain. We have expanded the list of the requirements. We have introduced also a new solution to the list of the mechanisms we discussed in the previous version. And specifically, we have also clarified that since we are discussing the usage of MPTV6 and NAT66, this is not something that the authors are supporting, but we are documenting the usage of those mechanisms in the field. And clearly, we have reviewed also the text and the conclusion. Next slide, please. So basically, the list of the solutions now includes 6 possible methods. So the first 5 were already discussed in the previous version, meaning the usage of provider-independent addressing, provider aggregatable addressing, the 2 cases with ULA plus MPTV6 or NAT66, and the 5th case, which is moving the handling of resilience to a central side of an enterprise. And then we have the 6th one, which is the introduction of application level proxies. Next slide, please. Now, about the, let's say, matching of the requirements defined in RFC 3582, so the guideline for using IPv6 in supporting multi-homing against the different solutions, we have developed, let's say, the section where we provide all the considerations, meaning all you may consider to select your proper solution for providing resilience. So there's no time here to discuss the table. You can find it in the draft with all the explanations that give you the pros and cons of every possible solution. But basically, you see that we have tried to match all the requirements listed in 3582 against the solutions we have considered in the draft. Depending on the type of the requirements, depending on what you are looking for to provide resilience to your site, clearly one solution could match more or less requirements as defined here in the list. For example, if you look for, I don't know, end-to-end connectivity, clearly the first 2 methods based on provider independent and provider aggregatable addressing work best, because ULA and MPT may work with some restrictions. ULA and NAT is not probably the best choice, but clearly, if you consider other requirements, for example, the convergence speed, in that case, the use of PA may present drawbacks because not all the corner cases are supported, as I said before. Now, moving to the next slide. From a theoretical perspective, so just looking at the support of the different technical requirements, if we list all the solutions, ideally, and I need to stress the word ideally, the solution based on PI may be preferred over PA, and then as the next step, you may have MPTV6, NAT66. But that is only under a technical perspective. As we have stated in our draft, there are many more reasons why an organization may choose a different solution, which is, for example, due to, let's say, policy-based considerations or security, or something which is not technical. Considering that, so we have provided a list of possible suggestions, but the caveat is that that depends on your real specific case. If end-to-end connectivity is probably the requirement you are looking at, well, as said, there are methods that are commonly employed and we do suggest. But if that is not the priority, at least the #1 priority, clearly, even the usage of ULA plus some form of NATing may be considered. And again, we are just documenting the usage of those solutions in the field. We're not supporting, let's say, those 2 cases, as we discussed also at the IETF117. Next slide, please. that's basically the conclusion, so we can move to the discussion. Since IETF 116, we have received a lot of very valuable and good comments. We have tried to address them. So please continue to provide your feedback. There is one point we'd like to share with you all. So we'd like to converge to the list of the solutions to be included in the draft. Just before our meeting, there was on the list a number of comments related to the usage of multipath TCP or multipath QUIC. We didn't have the time to digest, let's say, the possible contributions. It will be for the next revision of the draft. But we have the impression that that is something that could be used as a sort of optimization, but probably not to solve, let's say, the cases of multi-homing, at least at the network level. But we like to have your feedback and see if this is something can fit in our draft or not. And I would say that's it. So I see the first question here.
You say that ULA is an option if end-to-end is not a requirement. It's actually not an option because it violates the, it actually violates the business requirements. The business requirements typically involve you shouldn't, like you need to run IPv4 and you don't need to modify the hosts. So ULA does not work because you pointed out that you need to modify the policy table. But if you take any commercial operating system or some of the most popular ones, you can't do that. And so in order to change this, for example, on Android and iOS, you have to get like the vendors to change this. And so it's not actually an option in the real world. I think that's very important to note. And I think also it's sort of like a violation of 4193 because 4193 basically says that for global connectivity, you need global addresses. So I don't think we can actually publish this because it's a violation of the ULA spec and also doesn't actually meet the requirements. Because I think having a requirement that like it should work with IPv4 should be a requirement, and not modifying all your hosts should also be a requirement because it's not really a feasible option. So I think we should remove the ULA plus NPT 66B6 and the ULA plus NAT66. One of the questions on this slide is like, let's converge and list available solutions. I think we need to kick those out and say that this is an unsolved problem that needs to be solved.
Okay, so quick answer. Of course, we will review the list of the possible solutions, but I remember we have discussed that issue also at the last IETF, and it seems that we were converging in keeping ULA with NPT and NAT66 as a possible option. But in any case, thanks for your feedback. We will look at that.
Janinkova, Google. I also came here to talk about ULA and NAT because I did read the draft and I do not think we are not discouraging this enough in the text. Practically, I'm very curious. So you're saying it's potentially might introduce issues. Do we have practical operational experience with running that stuff and IPsec without NAT traversal over V6? Because I suspect that in many cases, we do not have complaints yet because it just works over V4. What would be very interesting to see IPv6 only network doing this and making sure your VPN works, your Wi-Fi calling works, and all those things which rely on ESP without ability to fall back to V4. I would like to hear from people who did that and confirm that works.
Okay.
Jeff Houston, former chair of the SHIM6 working group. So let me point out to you that the best conversations in the IETF are the ones that never end. It's the same conversation again and again. Site multi-homing in V6 has a 25-year pedigree, which is only a few months older than V6 itself. And SHIM6 encountered all of these icebergs. And you would do well to understand where we ended up and why it sank like a stone. So part of the constraint space is there is no taste or, if you will, accommodation of trying to do network-based address translation. The whole idea of V6 was not. And so if you're relying on that, it's kind of why bother? We just stuff more NATs into V4 and problem solved. The next issue, if you're going to do multi-homing, why? And the real answer is, I want to do failover. And not just that link's dead, bring down all the connections, bring up a new set. I want the connection to survive across a virtual rehoming between providers. Second constraint, kind of difficult because you've got to detect liveness and deadness. Third constraint, I want to obey the source address constraints. So when I switch providers and use their space, sorry, the other constraint is I need to use PA space. I can't make every site independently home because the routing space is going to die, blah, blah. Then when I switch providers, I need to switch source addresses. How do I then do internal routing to get to the right egress router when all I've changed is not the destination address, but I've changed the source address? So now the internal home network now needs to be source address routed. You're now getting some appreciation of the scope of the complexity, but that's not all. Because when we went and presented this at NANOG, the reception was, I don't know, somewhere between violently antagonistic and just no way in hell we're not going to go there. Because the network operators said, there is no way that we will let individual hosts make multi-homing routing decisions on our network. We operate the network, we control. So the Shim6 approach, which was really subtle, put a NAT in the stack of the host. And the host did liveness checking on all of this stuff, rendezvoused and made alternative, address selections. And as soon as it detected deadness, it flicked automatically. And as long as you could wave hands, do source address routing in the home network, wave hands kind of worked. And people kind of built stuff. But as soon as the operator said, no way in hell, just ain't going to give hosts that degree of autonomy, the work just stopped. So the question to you is, apart from re-encountering every single one of those problems, and you are, what's new? And let me offer the answer in case you haven't thought quickly enough. Nothing. Thanks.
Now, I
okay,
don't know.
folks, we need to move on.
Just wanted to answer Jen's point. No, ESP will not work on Android, for example, because ESP can't survive NATs.
Okay, let's take the discussion to the list. Mike.
Okay, extension headers may be one of those never-ending discussions that Jeff was just talking about. But the authors of this draft feel that at least this could help clarify the murky waters a little bit anyway. So we created this draft, and I'll try to go quick so we can get your opinions. Next slide. All right, so after a series of never-ending discussions on a variety of lists of why folks are blocking extension headers, Nick asked, if there's a document that discusses the use cases of extension headers, and at least we're not aware of any such document in the IETF. So the question is, should we create an informational document or just add use cases as was suggested on the list to an existing document, like the extension header limits, or maybe as it was suggested, Brian Carpenter's book or a Internet Society's portal or an APNIC blog. So we decided to create a draft. It's very, very initial, but we've included some use cases, and then the working group can decide what's the best way to go. Next slide. So our current strategy is to list the IANA reserved values that's already there. Give the description of the categories, the existing destination hop-by-hop options and routing types, and then get into the use cases. And the way that we've done it with the existing use cases that we defined and that we plan to define is list the existing header use cases and potential header use cases. And the more I think about that, it may be better to reword that maybe with standards-based use cases and non-standard-based use cases. I'm not quite sure yet. Next slide. So just as an example of the routing extension header use cases, so we list existing routing extension headers, SRH, mobility header, MLD messages, and then we have potential routing extension headers. There's one that's been proposed in the IETF using a multicast spit string. There's others that we've been informed about, which are with APN and ROSA that use extension headers in their architectures. So those are ones that we could list as well. Next slide, and I think it's the last slide. Yeah, so this is probably the most important question is this something that we want to tackle? Is this the right working group? If the IETF is the right place for this, if so, then is this a good format? There's probably some changes that we can make to that. Maybe we skip all the IANA stuff and just get straight to the use cases. And then we can worry about adoption later. So questions, comments?
So I haven't read the draft, so you can shoot me now. But in terms of advice, I would say, as long as you can, so just to get back to Jeff's point, right? In order to like avoid the never-ending debate on this, because it'll just never get published. If you focus on use cases that are actually in use today and are non-controversial, then that is actually, I think, useful, because then you can build on top of that. If on the other hand, you sort of end up saying, oh, this is a use case, and people think that that's a bad idea, your document will never get published. Oh, speaking from past experience, I mean, right? Like it's just very risky. And so in that sense, consider that. That's just.
Okay, thank you.
The next one is Tom.
Hi,
Tom.
Oh, sorry. Oh, right, Tim Chang. So, yeah, I think it is useful to document this. It's certainly informational and no more. There was a really good talk by Gori Fairhurst, who I think is over in Quick, not in this room, about the evolution of extension headers and their use. The thing that was interesting was he showed that there was about 3 or 4 that have been standardized in the last couple of years, which surprised me, like Altmark and the MTU Discovery one. Those probably aren't in widespread use yet, as Lorenzo's hinting, but I think it's worth documenting them, and any design decisions that were made as those were evolved to be the way they are. I mentioned earlier for the packet marking for the WLCG, we didn't use extension or the hop-by-hop extension headers because of certain issues, and maybe documenting those is also a good thing to show that the negative side as well as the whole story, if you like.
Okay, thanks.
Hi, Tom Herbert. So I guess my basic question is, if we do this, what is the expected outcome? Will this further the cause of extension headers? What's the ultimate intent here in doing this?
Well, one of the intents that we don't want to have is make any sort of value judgment on whether this is extension headers are a good idea or not. We want to be very generic. And so we're just planning to list use cases, whether or not they are good use cases or not, is just to define them. And then maybe this document will be useful for all the other documents that set limits on extension header use cases, or to say to not use extension headers. Maybe at least you'll have a document that says, okay, well, where are they being used? And this is the document that they can point to.
So one of the arguments that we hear regularly when people say don't use extension headers is that there are no useful cases. My counter argument to that is, well, we can't make a useful case of extension headers if there's no way to deploy them. So we kind of have the proverbial chicken and the egg problem. If we document these, it's one thing to document the use cases, but then will this just go into arguments about whether these are even legitimate use cases? I'm just trying to see how do we connect the dots here, because what we are missing, according to that argument, are the useful cases of extension headers. On the other hand, by the definition of extension headers, they're extensible. So we really don't want to just say these are the use cases. This is a mechanism that we want to say is continuously evolving. So how do you balance these? I guess that's the real question.
Yeah, and I'm not sure in this document if we wanted to say whether it's a useful use case or not, but we need to figure that out. Like, in my opinion, there should be a section of the document to at least show how people are intending to use it, even if they're not perceived as useful.
I have a partial answer to that. And the answer is it's possible to make extension headers work, and some people do make them work. And having a document that says these are use cases that are deployed today is useful if you want to go to someone who maybe is not very familiar with IPv6 and says like, oh, why would I need to even do this extension header thing? Why don't I just drop all of them? Because it looks obviously insecure. And like, this is not something I know from my IPv4 experience. And like, ah, this is terrible, right? Instead, if you say, look, these are useful things that people are doing with them today, think about it. Don't just like drop them out of hand, or like don't build your ASIC to drop them, right? I think that might be a useful thing.
Okay, so I think that's a good answer. And maybe that's the goal of this draft, is to not just document these, but to make that argument that these things are useful. And like Lorenzo said, they shouldn't be just arbitrarily dropped.
Okay.
Mikael Abramson. So yeah, basically Lorenzo said what I wanted to say. But I would like us to have a document where people either, if they configure the network to drop these headers, or people are making equipment that are not treating them, at speed and functionality and so on, to say that we have a document that says these are in valid use and they should be supported. And then it could be a next step for another document to have implementation guidance, or if there are more details needed on what needs to be supported, so that extension headers are possible in the future internet to actually be extensible as they were intended to be from the beginning.
Jeff, please be concise, because we have two presentations.
Yeah, fine.
Is that it?
Yeah. We have less than 20 minutes left, and we still have two presentations. So let's move on.
Can I just make one clarifying comment?
Go ahead.
So I just like to remind people, IPsec is an IPv6 extension header. So this whole thing that extension headers never work is clearly not true. So you need to be more precise in the way you talk about it. Hop-by-hop ones clearly have issues, but destination ones are in widespread use.
Thank you, Bob. Momoka, go ahead.
Hello, I'm Momoka, DNS over IPv6 enthusiast and also a student. So today, next slide, please. I've been here a few times. So the problem of DNS over IPv6 is that you can't fully do iterative name resolution because they are IPv4 only authoritative name servers, and it would be nice if we can have iterative resolvers who only have an IPv6 interface to be able to do iterative name resolution. And one of those solutions is to have 464 XLAT, but it is not completely widely available, and so this is why we have this draft. So a draft documents the behavior of how an iterative resolver can do IPv4 to IPv6 translation inside the DNS iterative resolution software, and so it will change the IPv4 address of the authoritative name server to IPv6 by putting the prefix of the NOT64 prefix and then sending it. The NOT64 will change it to an IPv4 packet, and then it will be able to be sent to the author name server. So this technique is not new, but it is, I thought it would be worth documenting since DNS uses IPv4 address literals, so it can only operate using IPv4 literals, and this is a solution if until all authoritative name servers work with IPv6. Next slide, please. So we've had working group adoption call a month ago. Thank you for all the people who have responded and gave feedback. We've got a lot of feedback from this V6OPS community and also from the DNS ops community. And I think we had mainly 3 concerns from the feedback. 2 are up here. One is if this is scope for V6OPS or should it be for DNS ops. And so the focus of the draft is how to send packets to the authoritative name server and not about the DNS resolution itself. So I think it should be, well, if this work should be done, I think it should be done in V6ops. And Tim, the chair of DNS ops, also were like, I think it's okay for this to be done in a V6ops. I hope I didn't code that in a bad way, but I think that was what he said. So next, DNS64 and DNSSEC. So DNS64, DNSSEC doesn't work with DNS64 with the because DNS64 changes the queries, but so I think my draft was misleading as it had mentions of DNS64, but in reality, what the mechanism that is documented in a draft isn't actually related to DNS64 because it just does translation inside the software, IPv4 to IPv6 translation, and it will be sent to the NOT64. So the DNS64 doesn't come into the story. So the thing about DNS64 and DNSSEC not working should not be related to ODRAFT. So we will erase references to DNS64, and I think that will make it okay for DNSSEC. DNSSEC will not be in the scope of this draft, so I think it will be okay. And I think the third concern was, is this worth even being documented? Because this is very niche and it's limited to DNS. And is it worth having time on it when we have other drafts talking about similar topics? And I think that has a point, but DNS iterative resolvers working solely with IPv6 packets I don't think is a thing currently, and I think it would be cool if it is. And there were people on the list who thought this draft was useful, so I think that is what some people think. So changes that will be made to the draft. So since working group adoption call, I did not have time to revise the text and update anything. So the current draft is what it was before the adoption call, but I plan to delete mentions of DNS64, as I've said earlier, and also include that both 464 and doing address translation inside the resolver are also solutions. So for doing 464 would be like a bit maybe better option, but not all operating systems may have CLAT implementation. So until then, this documentation proposal will be a nice bridge to it. So future work. So I should have wrote future work in DNS ops. So talking with Tim from DNS ops, and he was talking with Mark Andrews about how BCP 91, obviously 3901, DNS IPv6 transport operation guidelines, I think it talks about DNS with doing DNS over IPv6 protocol. And that was it's a BCP written 20 years ago when IPv6 was not deployed widely any. And I think now there are a lot of alternative name servers that run IPv6 and a lot of iterative resolvers that have IPv6 connectivity. So I think it would be nice if this was updated, and this work will be done in DNS ops, not here. So I just put that here because saying it may be done, this work may be done in DNS ops. No. So updating BCP 91 may be done in DNS ops. Okay. So yeah, so I will make the changes to the draft and send that to the list. Okay.
Warren.
On 464xlat, I mean, I wrote an implementation of it, right? But 464xlat is intended as a compatibility measure for things that need to talk to IPv4 and where you can't modify the apps. Okay, I mean, if this server or whatever is just a name server and it doesn't need to run IPv4 only apps, then 464xlat. I wouldn't argue necessarily. I would disagree with folks who say that 464xlat is a better solution. If all you need to do on this thing is run a v6 only name server, then you don't need 464xlat. You can just do this. So anyway, so just wanted to say, like, I'm sure there's strong opinions on the other side as well, but don't necessarily think that that's the prevailing opinion. And the other thing is, like, yeah, for 3901. Yeah, I think, yeah, you should probably also say that every recursive should have access to the v4 internet, right? Because this is, because if not, you like some sort of connectivity. It doesn't have to be like an IPv4 address, but so of course this is about the, I think the first one should be like, well, it should be able to talk to the v4 internet.
Okay. Thank you for the first comment about 464xlat. Thank you.
Warren Kamari, Google. Just a quick note that regardless of where this document ends up being discussed, DNSOP or v6op, the other working group will be CC'd on the working group last calls, etc. So everybody will get to see them.
Thank you, Warren. Okay. Let's move on.
Thank you.
Thank you,
Okay, everybody, I'm here to talk about V6 and putting PDs in the lands. It's been talked about a couple times today. Next slide. I presented on this last IETF. So the problem statement here is service providers have done a great job getting large prefixes to the edge of the network, and then that's where they stay. They get to your home gateway, and then they often don't leave it. It's the only thing that's able to provision it. This is a draft trying to push it beyond that and doing prefix delegation on the LAN side of CE routers. So one of the problems that immediately came up when we went to do this was there are two methods for getting prefixes out into the home. There's flat and then there's hierarchical. And so what the draft, they're both defined here, right? The hierarchical is you take the tree, you break it out, you make guesses on how many is going to be on each side. You could end up with unbalanced trees and all of that. It's complex. Flat is much simpler, but also has some drawbacks because it's much simpler. Next slide, sorry. So a couple things that have come up since 02 to 03. So that's just to set the stage for what we've been doing here. Because this keeps coming up, basically saying why we chose flat, or why I chose flat, I guess, in this case. And that it's easier to do. Hierarchical is written down. It's in the Cable Labs draft. It's not in a ton of home gateways we've seen. We've definitely not seen it anything outside of a DOCSIS network, or at least I have not seen it. So I think there's some issues there with the complexity there. So we chose flat to try to help move this forward and make it a little bit easier. So I talk about that more in this draft, saying, hey, that there was not a whole lot of mention of why it wasn't chosen, so I added text for that. And then next slide. Can't remember. Yeah, so the only other thing I added more text about, which I think we've hammered enough today, was the multi-site is out of scope. So multiple carriers talking to this is not part of this draft. This gets really complicated really fast, and you need a routing protocol, and you need to figure out your egress. Insert Jeff's comments from earlier. This is a really complicated problem that's been not new, and so I put more words around. Instead of just saying it's out of scope, I gave some words about why that's out of scope, that it's just too complex to do in a document like this, and that's not the goal. Our goal here is really to get prefix delegation turned on the LAN networks. So that being said, you know, this is important for border routers that want to support things inside the house that actually do real prefixes and not ULAs. One thing that's come up for people who want to have a million different ways to subdelegate, I'm not super excited about this, but I'll do it. We could just document them all. They do interact in weird ways, and we could put those interactions in here and document flat hierarchical. The goal being just, hey, we want PDs turned in the house. We don't care how you give them out. You have options. You can do it all these different ways. There is some downsides to that, but if that's what's holding this up, I'd be happy to document all of those and just put them in here to move this forward. Because the bigger issue is the longer we go, people are going to get real creative and have started to get real creative of not using PD in the home, which is not what we want. So I would rather get this out and available to home gateway vendors. And I think that's everything I have. So questions?
On the flat versus hierarchical debate, I think one thing that you could add to the text that you've already added is that flat is inherently more efficient in terms of address space, right? So in a network where you only have a 60, hierarchical is really not going to get you very far.
Yeah.
Right.
Sure.
So I think that's actually really important, right?
Okay.
Because, and there are a lot of networks that only do 60s. I think saying, you know, that hierarchical is like not forbidden at least, or like briefly just documenting how it works.
Yeah.
It probably is already documented, but I think,
Yeah, I think it's in the HNCP draft, so I think I could get away with that if I needed
in
to.
particular, right? Like if an ISP wants to support just like handing out a big chunk only at the top level. First, like there's a difference, I think, between ISP-CE router and something else, because the ISP-CE router is probably like, in some cases has to be the first hop because it's got like an on Ethernet interface, and like you can't like put it behind anything else. So that could have like, for that type of box, hierarchical does make sense. You could say, okay, like you want a 60 code, okay, have at it. You want all of my address space, have at it, or something. So that might make sense. So
Okay.
yeah.
I think that might be a middle ground. That might work, Lorenzo.
And the other thing is channeling Eric, who doesn't know he's being channeled, but it would be nice to express how you could like at least not break multi-homing in, for example, a simple case where there's like one link at the top with 2 routers, and say that everything else is out of scope. At least, because I think you could say that like the problem of routing is out of scope, and you can say this is only about how you distribute addressing.
Yep.
And that's like, because realistically, once you've distributed the addressing, I think, you know, it's not that different from like something where you're on the link with 2 routers. Maybe not. I don't know.
I'll think on that. I just get nervous about opening this can.
Yeah, definitely don't try to solve the general problem.
No,
Definitely with
please
you. But like
no.
saying that this won't break at least simple cases would be nice.
Okay. I can maybe get on board with that.
Michaela Abramson. So as per the draft here, we're discussing it before about nodes or whatever we ended up calling them, also requesting PD. Is there some advice there to give them here, or do you want to continue?
No, this one's really, it's a good point. We're really talking about routers.
Okay.
We're requesting it, and I'm specific about routers. So this goes more to the case that Ted talked about with snack routers needing to get these.
Okay. Because I think, so I'm mostly been involved in like OpenWRT and so on, and I don't know if they actually do this multiple/64. So getting this out as an, you know, this is how we think it should be done to everybody, I think that's very useful.
Yeah, it's not in there now. I've played a little bit. We're working on getting some stuff into the OpenWRT in purple.
As far as I know, the default they're shipping is to give the hierarchical model giving a larger one, and then it starts to subdivide them up. That's the strategy they've chosen. So if we're going for the flat model and that's the advice, then I think that's good advice to give everybody so that they know what to expect when they come.
Thanks. Yeah, my last question here is, can we move this towards adoption? I think people haven't been giving a whole lot of technical content, so I think we can do an update, and then I'd love to get this for an adoption call if possible.
Okay.
Thank you.
I think that we will take it to the list.
Perfect.
Okay, so this concludes the V6 OPS session. Thank you, folks.